All right, guys, this is worksheet 1, chemical reactions. Part 1 is kind of a review of chemical formulas and naming. For example, if we see CaCl2, we know that's calcium chloride. It has 1 calcium and 2 chlorides. If we look at number 1, K, guys, you got to know this one. What is K? That's right, K is potassium. All right. And since we see 1, 2, 3 capital letters there, we know there's a polyatomic ion there. And there it is, OH. And we look at our list of polyatomic ions and we see OH is hydroxide. This is potassium hydroxide. This is what they put in drain cleaner. All right, and it has 1 potassium. It has 1 oxygen. And it has 1 hydrogen. Okay, this formula here looks pretty complicated, but we all know what Na is, right? Hopefully you do by now. You know that Na is, that's right, sodium, our friend, number 11. And so that's sodium. Then we see this big old long thing right here. We know there's a polyatomic ion there. And this one is called acetate. C2H3O2 with a -1 charge. That's a polyatomic ion known as acetate. Sodium acetate. And this has 1 sodium. It has 2 carbons. It has 3 hydrogens. And it has 2 oxygens. All right. PbI4. Now, we know Pb is lead, right? Well, you better. And we look at lead on the periodic table and we notice, hey, it's multivalent. Do we have lead 2 or do we have lead 4 here? Well, if we have 4 iodines and we know that iodine is a -1 ion, that means that's a -4 charge on this side, so that has to be lead 4. And that's IV for you non-Romans. Lead 4 iodide, and that is 1 Pb and 4 Is. Okay? MgSO4, 1, 2, 3 capital letters. Hey, there's a polyatomic ion there. Mg, you know magnesium, right? Mg, magnesium, not manganese, magnesium. So this is going to be magnesium sulfate. And that's going to be 1 Mg, and it's going to have 1 S and 4 oxygens. Okay, here we're going to go from the name to the formula and do the same. We're going to count the elements. Okay, so calcium. Calcium is a Ca, and calcium is in group 2, so it's going to form a +2 ion. So we put a +2 as a superscript. Hydroxide, you remember hydroxide from up here? It is OH and has a -1 charge. This is listed for you on your list of polyatomic ions, and it's in the -1s. So there's OH with the -1s. Crisscross, that 2 is going to come over here. We put that in parentheses, so it's going to be Ca, parentheses, OH2. This 2 applies to everything in the parentheses there. So when we start to count, we're going to do 1 calcium, and we have 2 oxygens, and we have 2 hydrogens. Oh, looks like I skipped number 5. My bad. This is just a binary ionic. You just name it. Al is aluminum. S is sulfur, and we're going to ide it because it is on the ide side, so that is sulfide. And we are going to have 2 aluminums and 3 sulfurs in that. Okay, magnesium oxide. This is a binary ionic. And Mg is a +2. Why? Well, because it's in group 2. Oxide means oxygen, and oxygen is a -2. Okay, so crisscross, 2, 2, cancel, cancel. This is just going to be MgO. 1 magnesium and 1 oxygen. 1 plus 2, 1 minus 2, zeros out. Okay, calcium, remember calcium is still Ca with a plus 2. And then sulfate, remember sulfate up here is SO4. And we need to find the charge on sulfate. So we look on the back of the periodic table and we see sulfate is a minus 2. So that 2 comes over there, that 2 comes over there. They cancel out and it's just CaSO4. 1 calcium, 1 sulfur, and 4 oxygens. Lithium nitride. Lithium is group 1 metal, Li, and it's a plus 1. Nitride, that means we're going to look on the ide side there, okay? And nitride is N, and it has a negative 3. And that 3 is going to crisscross over here, and we have Li3N. We're going to have 3 lithiums and 1 nitrogen. 3 plus 1's 1 minus 3. Okay, sodium phosphide. You remember sodium is Na. It is also an alkali metal, and it's also a plus 1 ion. And phosphide, just like nitride, is also a minus 3. So these are going to combine in the same ratio as the lithium nitride. That 3 is going to come over there, and you get Na3 P, 3 sodiums and 1 phosphate. Sorry, phosphide. Okay, and that's how you do part 1. Okay, so here's part 2 all filled out. Hopefully you can read those. These could be straight off of the notes, but here's how they look on paper. Okay, this is part 3. What we're going to do here is we're going to practice counting. There's a little math involved, but I think you can do this without using a calculator because you're pretty smart. Okay, so what we're going to do is we're going to count how many of each element are found in the reactant side of the equation and the product side of the equation. Okay, so if we look at our first one here, we have 4H2O. This is our coefficient. The 4 is a coefficient. The 2 is a subscript. Okay? So the formula, H2O, is formula for water, tells you in each molecule there are 2 hydrogens and 1 oxygen. The 4 tells us there are 4 molecules there. So if we have 4 H2Os, we are going to have 4 times 2, we're going to have 8 hydrogens in there. Okay? We are also going to have 4 times 1, we're going to have 4 oxygens there. And here's our coefficient for iron, and we have 3 irons in there, so we put a 3 there. Now, if the equation is balanced, these numbers and these elements should be the same on both sides. Let's look. We look right here, we have Fe3O4. That tells us we have 3 irons, and we have 4 oxygens. And here we have H2, which is the formula for hydrogen gas, because it's one of the Brinkelhoffs. And so we're going to have 8 hydrogens. We are all balanced there. You see how that works? Okay, let's look at the next one here. If there is no subscript, that means there is 1. And we have 2 chromium 3 chlorides. This is chromium 3 chloride because chloride's a minus 1. There's 3 of them, so it's a minus 3 plus 3, so chromium 3 chloride. So we are going to have 2 chromiums, and we are going to have 6 chlorides. 2 times 3, 6. So we have 6 chlorides. So let's look over here. Now, got to be careful because chloride appears in two different products. Okay, so in this one, which would be chromium 2 chloride, we have 2 chromiums and we have 4 chlorines. But if you look over here, we have 2 chlorines here, and 4 plus 2 equals 6, and we have our 1 zinc. And that's all balanced. All right. GA, gallium. We have 2 galliums there. We have 3 H2SO4s. H2SO4 is sulfuric acid. And so we have 3 of those molecules there. And so we're going to have 3 times 2, 6 hydrogens. And we're just going to count SO4s all together here. This is the tricky part, guys. Don't look at the 4. Okay? How many SO4s do we have there? We have 1 SO4. Now, there are 4 oxygens there and 1 sulfur, but we have 1 SO4. Now, let's look at our product side. We have 2 gallium, and we have, oh, my bad, I made a mistake here. 3, we have 3 H2S, 3 sulfates right here because of the 3. I saw that because I came over here and like, well, there's 3 sulfates over here. There should be 3 sulfates over there. And of course, 3 times 2 gives us 6 hydrogens there. And there we go. All right, last one. Lanthanum nitrate. Don't see that very often. All right, let's see. We have 1 lanthanum. We have 3 nitrates. We have 3 NO3s there. We have 3 ammoniums, and H4 is ammonia. We have 3 of those. And we have 3 hydroxides. Remember, the 3 is going to affect everything in that formula right there. And so there we go. Now we look over here. We have 1 lanthanum. We have 3 hydroxides. And we have 3 ammonium nitrates. So we have 3 ammoniums and 3 nitrates. And perfectly balanced, as all things should be. Okay, this is part 4. That's IV for you non-Romans. Okay, here we're going to look at some chemical equations, and some of them are balanced and some of them are not balanced. Remember, chemical equations should always be balanced. So, as soon as we find something that does not match up between the products and the reactants, we're going to say no. All right, so we look. How many aluminums do we have here? We have 1 aluminum, 1 aluminum. That's good. We have 3 chlorides, and we look over here, and we have 3 chlorides. Okay, good. We have how many hydrogens? 3 times 2. We have 6 hydrogens here. And we look here, we have 3 hydrogens here, and we have 3 hydrogens here. That's 6. We have 3 oxygens there, and we have 3 oxygens there. This one is balanced. Okay, and we look at this one right here, and we have 10. Remember, 10 is a sin, and there's 1 of those, and there's 1 over there. We have 2 potassiums, 2 potassiums. We have 2 oxygens. We have 2 oxygens, and we have 2 hydrogens, and we have 2 hydrogens. That one is balanced as well. Now we look at number 23, and on number 23, we have sodium hydroxide plus calcium sulfate gives us sodium sulfate plus calcium hydroxide. So we have 2 sodiums, and we have 2 sodiums. We have 2 OHs, and let's see, we have 1 calcium, 1 sulfate, 1 sulfate. This one is balanced. Actually, there's a mistake on this one. This one should be Na2, because this, if that 2 is there, that tells us there's 2 sulfates. So no, that one's not balanced, because this would have 2 sulfates, because the formula's wrong there. Okay, 2Al, 3O2. Well, looky here. We have sodium in our products. We do not have sodium in our reactants. You cannot have sodium in the products if there is no sodium in the reactants. So, no. All right, and then we'll look at the last one here. Calcium aluminum oxide. Well, I don't know what the heck that is, but anyway, we have one calcium here, we have one calcium there, we have two aluminums, and we have one aluminum. Not balanced. Okay, part 5. That's V for you non-Romans. All right, so here we want to find these things in this chemical reaction here. So the reactants, well, these are the reactants right there. So that's going to be B. Products, those are your products. So that's going to be C. Coefficient. Well, we see here's a coefficient right here. There are no coefficients here. So coefficient would be in the reactant side. Subscript, we see subscripts here, and they are in the product side. And of course, yields is the arrow. And that, my friends, is worksheet number 1. Good luck.